maximum difference between even and odd frequency part 2. Part 1 was yesterday. Guess I didn't do part 2 previously. You're given a string as an integer k. Your task is to find the maximum difference between the frequency of two characters and a substring of s such that subs has a size of at least k. Character A has an odd frequency, character B has an even frequency. Return the maximum difference. Okay, so here the substring might be 122 or 223 or 233. I think that's the only way you get an odd and even. Like the even has to be 2 and the odd has to be 1. So 1 minus 2 is going to be -1. Here the odd could be 3 and the even could be 2. Like, can only get up to the highest odd is going to be 3. There's 4 ones and 3 2s. And then the lowest even that you can get, I guess non-zero even, is going to be or something that is even there. It's going to be 2. And are you guaranteed? Yeah, you're guaranteed to be able to generate this. Here the odd is 1, the even is 2. Okay. Let's think about this. So you can start by considering for any given string what the way of generating the string with the largest odd frequency is. For any given string, how to generate that string with the largest odd frequency, which I guess could mean that from a given starting point, you're going to go to well, the start and end of the sequence, if it's kind of a minimal string, is going to end with one of the two frequencies, one of the two characters. Let's say A and B are the two characters that we're dealing with the odd and even frequencies here. It's going to have an ending that's one of the two characters. There might be extra characters before or after that substring, but it's not going to be relevant if you're dealing with just the frequency of those two. This doesn't necessarily have to end with the same character. Like, it could end with the 1, but doesn't need to. So if we confine ourselves to endings where you're dealing with the other character that is the frequency within the frequency calculation, then what? Maybe you can have a sliding window. The window slides out all the way to, well, if at a given start you're dealing with the odd frequency start, then the window slides out to where you have the most odds of that amount. No, that's not necessarily true. It can slide out to be where there's a lesser odd of that amount, but then there's also a much lesser even lowest even frequency. Like for instance, let's say you had ones as the ones that digit 1 is your most common odd digit, or odd, the most common one where you can have an odd frequency. So like you have, let's say 1, 1, 1, and a bunch of ones later on, right? But let's say this last one is, there's like a bunch of 2s, and 2s is your lowest frequency even. So you don't want to capture the last odd, because then you'd have to also capture these evens. Huh. What if you the lowest frequency even, the lowest frequency even. If you were to extend out the 1 to where there will be odd frequency 1s, then if you extend out the 1s so there's odd frequency 1s, then for each substring of that, there's going to be a low even within that substring. And that low even would take a long time to calculate. I mean, it would take the length of the substring to calculate. So probably not that. The string itself is 3,000, no, 30,000. Oh, S is only 0.4. Interesting. The input is generated, yeah, okay. So you're only dealing with 4 characters, or 5 characters. 5 different type of characters. So what if you you have some sort of maximal odd amount, and you have some number of substrings that might be generated with that maximal amount of odd frequency, and then each of those substrings there's going to be a low even amount, and then you'd have to figure out from there. Alright, so it's only for 5 characters, 0 to 4. So we could so there's only certain combinations actually, right? Like in terms of you're using the odds for 0 and evens for 1, or using the odds for 1 and evens for 2. So there's only certain combinations of what is the low frequency of what is the actual character that you're using for the low frequencies and high frequencies. Huh. The low even is always an increasing amount if you were to further extend out the substring. And the high odd is, no, that's not true at all. The low even could be a decreasing amount. So for instance, if you had a string that was 1, 1, say there's 4 2s and a 1. So if you had your odd be 3 1s and your low even's going to be 4 2s. But then if you extend it out further and you said that there was 0 0 1 1, now your high odd is now increased to 3 to 5, but your low even went down from 4 to 2. So it's possible for your low to be decreasing. It's not possible for your high odd to be. It's not possible for high odd to be decreasing. It has to be increasing. So that matters because there can be assumptions made about what happens to those values when you extend out the window, the substring window. 2 2 2 2. So is it possible that for every index in the string you track the number of track the count of the you track the frequency of each character 0 through 4 up to that index. So it can be a pretty quick calculation as to how many of the other characters there are within that window. So for instance, if for every index in the string you know exactly how many characters 0 through 4 have been seen up to that index, then it's just going to be a difference between the count of like character 0 at this index versus the count of character 0 at a later index to figure out how many zeros occurred between them. And then what? And then so you would quickly know which was kind of the smallest even. If there is, let's say we're going like odds, like let's say 0 is the odd. So you go 0, you go from the first 0 to the third 0, compare how many evens of, if there are an even amount of 1, 2, 3, 4 between those zeros, you determine what the low even amount is, and then that could be one answer. So I think that's the starting point. I think this is, I think knowing exactly the counts at each index, track or counts each of 0 to 4 at each index. So let's say this is going to be counts, which is a 2D array. This is going to be 0 times the length of the string, which is going to be s. Oh, it has to be the length. The substring has to be at least k. Okay. So counts times n for digit in the range of 5. And then for every index in range n, let's say the current count is going to be maybe let's just have an empty array. The current count have an empty array and make copies of the empty array. Is that any faster than doing manually 5 operations of counting? Not going to be any faster. You can say current counts is going to be all zeros, and for every index the value is value is going to be assets index made into an integer. No, this doesn't quite work right. That does work. In the current index plus equals 1, and then counts dot append the copy of this current array. Okay. And let's say counts is that original. Current index is out of range. Okay, let's go ahead and print out the values. Oops, current of the values. So if it's a 0, then it increments 0, 1. Okay, so this is what I expected, or what I was hoping for. So at the first index, 1 appears once, so the frequency right there is 0, 1, 0, 0, 0. 0 is for the other characters. And then index 2, 2 is once, so 2 is incremented. Index, the third one is 2 as well, so there's another 2. Fourth one is 3, so it goes up to 1. Okay. Alright. There, got it. So how to use that? How to use that? If you have if you have a maximum odd, then be comparing for any, so your substring has to be at least k. So for each starting point of your substring, and then for every ending point in your substring, which is at least k more than your starting point, you would need to determine if there is whatever the maximum odd is, and whatever the minimum even is, and just do a difference between those. Like that'd be k squared, right? Like is that k squared? For every starting point, which is there's k starting points, or there's n starting points, and then for every ending point, which is still roughly n, I think that's n squared. I mean, n squared times like 5, because you're doing like 5 operations there. I mean, I think that might work. It's not particularly efficient. So for every index in the range of n, and then for every end index in range of index plus k to n. All right, I got to take a break. for every index that I start at, and then for every index after that. Okay, so I'm going to say that there should be a maximum answer. What should the value of the maximum answer be? I guess it should be negative infinity. And then so if the index is 0 as a starting index, and the index is like k is 1, it can't be 1, but like k is 3, I guess, is the minimum you could have for any valid solution. So 0 to 3. If the starting index is 0 and the index is 0, 1, 2, 3, is that what I want? So if I subtract this, will I get that? If I subtract this by this, will I get the frequency for this? So I don't think so. It looks like it's like an off by 1 issue, because I have a 3 within that sequence. So I think this should probably be, counts should actually start with appending the current, all zeros. I guess counts should be an array that has an array of all zeros already within it. Okay, so index 0 to start is all zeros. Index 3 to end would be 0, 1, 2, 3. I have to subtract the frequencies there. It is the frequency of the characters in the first 3. Okay. So for each index in the start and n index, at least k more than the current start, and the frequencies of each characters is going to be if I do 2 arrays subtractions, can I do 2? Can you subtract 2 arrays of the same size? Use a list comprehension. Use a map. Okay, I guess you can use a list comprehension here. So the difference is equal to an array that is say n frequencies is count at an index, and then the start frequencies is counts at the index, and the difference frequencies are the number of each character between those 2 indices, which is going to be d. Let's see about this. And frequencies at let's say d minus n minus start frequencies at D for every D in range of 5. And now if there is an odd, so then I need to parse through the actual frequencies. Let's say the high odd is going to be initially -1, and the low even is going to be -1 as well for every D in differences. If D is an odd number, then high odd is equal to the maximum of high odd and D. Else if it's an even number, then the low even is equal to the, okay, I can't have this be the min. The -1 is going to be lower than any other low even. And also it can't be 0. Else if D, so if it's not odd, then it's even. But else if the D is not 0. So non-even number that's 0. And the low even is going to be, so the low even can't start at -1, that's too low. Probably need to start out with, I could start out with maybe an arbitrary number that's impossible, like n plus 1. Like it could technically be n. I guess we just make it n, because there's going to be something better than n. It has to be, right? But even if it was really bad, then it's going to be removed at some point. Low even is going to be the minimum between low even and D. And then that goes through all the differences. And then the answer is equal to the maximum of the current answer and high odd minus low even. And then return the answer. Starting frequencies is not defined. Null. That's unfortunate. Null. Zero, 1, 2. Starting at 0 and 3. How did I get null? What? For every starting index, and then for every ending index. Actually, index plus k could actually be 10. Maybe it could be equal to n, so maybe it's n plus 1. Okay. So let's not print out everything and see if that runs on a bigger test case, which is it might be too slow. It is going n squared. There's a fair amount of computation and other values. Yeah, too slow. Let's see. Let's say for this test case, what is the size of S? this looks like maybe size of S is not S itself. So this test case is 5,300. Oops. So it looks like, yeah, 5,300, which is maybe an order of magnitude less than the actual thing. I guess if I did 3 times 10 to the 4th, 30,000. I guess that's too big for it to be n squared. Yeah. Okay, so time to optimize. So yeah, unlikely that this would have been so simple as a simple n squared approach. But I think this is fine getting the counts. That's pretty fast. So how do you approach it? I think maybe if I were to think about colors, like odd and even as being 2 colors. So for every index, each of the characters 0 through 4 has a color for the frequency depending on the parity, the even or oddness of the I use parity, but should I use the oddity? The evenness of the count of that index, the count of that character index. And what you're really looking for is indices where, so if you have a starting index and an index where the parity or evenness of a character is the same, the frequency of that character is going to be an even, because it's like 1 minus 1 or 3 or 1 minus or 5 and 1 or 2 and 8. So if they have the same evenness of their frequency at the start and index, they have to have an even number between them. Although that technically that even number could be 0. But in any case, if they have different evenness at those indices, then they would have an odd number of the odd frequency of that character in those indices. I wonder if parity is the correct word that I should be using here. Word for even or oddness of a integer. Okay, parity. It is parity. Does that help at all? I mean, that could help me identify where, if you have a certain character to start, then if you care about maximizing, or if you care about looking at where if you have a certain character to start, doesn't work. Like, you don't really care about necessarily looking at just substrings that end in that character, even if the ending of that character kind of helps define the oddness or evenness of that character, or the parity of the character. Because it could be that you want to end in the other character. So what? One, two, two. 1, 1, 2. 1. So how would I expect the algorithm to look at this? In a non-optimal fashion, if it knows that 1 is part of the sequence of part of the frequency, it's going to go 1, it's going to go 1, and then where does that go? So if I were to think about just where I'm dealing with odds, it's going to go 1 to 3. So the character 1 could be an even start. So character 1 could be an even thing. So if the character 1 was the even frequency within the optimal substring, then I would go to where there are even amounts of 1s later on. So like here, and that's the only one. And then I were to check if there's an odd amount of things between those and what the highest odd is. And the highest odd would need to be increasing by more than 1 each time, because as I increase from like 2 to 4 to 6 to 8 even ones, then the odds would need to be increasing by at least that much at some point down the chain in order to increase the answer to have a higher maximum odd minus even. Huh. Ha 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 ha. Okay, so I don't know if that lineup thought actually helps at all. Probably not. So if you go, so one, that's the only other ones, that's the even. If you go odds, then there's like 1 odd here, and then, oh actually, so there's two 1s here, and then if you go here, there's 4 1s and 3 2s. So your answer is initially -1, 3 minus 4. And then go to the 1. If you go evens, then you go to the other 1. So it'd be 3 2s, 3 2s, and and two ones. So your answer there is going to be 1. And then you go, so that's evens with 1. And then go here, evens for 2 is going to be 2 eat 2s. And that's the only one. And you go here, evens for 2s is going to be 2 2s. Go here, evens for 2, there's none. Go here, evens for 1, there's 2 1s, but none of those work. So you could have looked at just that. Although technically the correct answer was, or the first answer was actually that. I wonder if you would use, I wonder if it's possible to use dynamic programming here. Dynamic programming would be like, what, maybe 5 times n? 5 times n, maybe? So, dynamic programming. I don't think so. Well, how would dynamic programming work here? Where at each index, yeah, it's a hard thing because when you increase the index, when you increase the index, you could possibly be invalidating previous stuff. Maybe. You kept track of where all the ones appeared. You kept track of where all the ones appeared. Nah, what I'm thinking definitely in terms of n squared right now, I think. If I do indices to every other index where that's the starting index, that's just not going to work. Let's be more efficient. Huh. So if you have 1, 2, 2, 3, 3, you only have one odd, and evens that you can get is like 2 evens. You can never get to 3 odds. And your low even is always going to be at least 2. All. Yeah, your low even is at least 2. Can't be 0 because then it doesn't show up at all. Can I somehow do a sliding window? So how do I know how far to slide to the right? Okay, a huge 5,000 long string. So 1. How do I know what to do with this one? How do I know how to find the needle? The substring needle in the massive haystack. Doobie doobie doo. Okay, so go 1. Go 1. Then extend it to sliding window. I don't know how you'd know how far you to slide it out to. Like in theory, the answer could be the whole string. In theory, the answer could be the whole string. So for every character, if you go from that character to the next of that character, you change the parity of the frequency of that character. So there's 1, 1. If you go to the next one, it becomes 2 1s, which is going from odd to even. So you change the parity of that character. And then you might have some more of the characters between them. And that might change the parity of the stuff between. That might change the parity of the stuff between, and also might change the frequency of them. Well, obviously that changes the frequency of them. So let's say you had an array of strings that was mostly non-ones. So let's say you have like just 10 ones in your string, and like stuff between them is like so you have a bunch of that jazz. So when you go 1 to 1, 1 becomes even, or odd to even, odd or even to odd. And then you're increasing the counts of everything. Well, you're increasing the counts of the non-ones. Possibly, I mean, possibly not. It could be just 1 followed by 1, but for the most part, you're increasing the counts of the other stuff. How does that help you, though? We can condense that information. So if you go 1 to the next one, and maybe you start with the assumption that 1 is a part of your answer. One is part of your answer. So if 1 is your min even, because right now there's an even number of 1s, then your answer would be the highest odd amount between those ones. And then if you extend out to the next one, then now 1 is your odd, and you'd be looking at the minimum even of everything first set plus the second set. Whatever the minimum there is. And then if you go from an odd one to the next even, to the next one, so that's now an even of the ones. And now you're looking at the highest odd amount in between the start and end ones. The lowest even amount. So I'm looking at the highest odd here. Yeah, the highest odd here. And here the ones is your odd amount. So you're looking at your lowest even amount. So the highest odd amount combining sections of an odd number of subsections between ones. Highest odd amount combining subsections between ones. Highest odd amount combining an odd number of subsections between ones. And the lowest even amount combining subsections between the lowest even amount combining subsections between combining an even number of subsections between ones. Highest odd amount combining an odd number of subsections between ones. Adjacent subsections. So yeah, so if there's 2 ones, then there's 1 subsection. There's 4 ones, there's 3 subsections. So 1 is an even amount, the number of subsections is odd. Or 1 is an odd amount, and the number of subsections is even. And you want to maximize the odd stuff, maximize the stuff from the odd subsections, or minimize the stuff in the even subsections. Does that help at all? Oof. Does that even help? Do. Two, 3, 4, 2, 0, 3. Least k size. I wonder if k size actually I don't know if this actually provides any sort of extra complications. I don't know. Like k could be the whole substring, so I'm not sure what's the point in having that thing. It's not really I wonder. Could I do a binary search here? Could I do a binary search here? So binary search would require that I be able to, for a given value, for given like a potential value of maximum difference, using a O of n time check to verify whether or not that value is okay or not okay. Could I? Could I say that my guess is the maximum difference is going to be, the maximum difference is always odd, so let's say the maximum difference is 11 for a string of extremely large size. Could I say my guess is 11 and then verify that that is right or wrong? So for all substrings with here, there's no substrings that have a higher than 11 difference. Or there exists a substring that has a higher than 11 difference in a single pass. So what would that require? So if I said 11, I said 11 was the maximum. 11 was the maximum difference. And if I ever see anything that has a higher than 11 maximum difference, then I can immediately return false. So I start by maybe creating a window. So we have a starting point for your window. If your maximum difference is 11, if your potential maximum difference is 11, then you would extend it to extend the window until you had something that's higher than 11 for a character inside that window. Higher 11 or higher, 11 or higher odd frequency. So like you extend out here until you get to like maybe 12 odds or 11 odds, maybe it's 11 ones. Well, no, it has to be higher than that. Even it has to be at least low even can be at least 2. So if you're testing 11, then you have to go out to be 13 evens. So you're going to extend this out until you have 13, let's say, ones. And then you test to see if the low evens is 2 or less, well, 2. And then if that doesn't work, then you extend it further until you see your next one, or until you see like 15 ones. And then you test to see if the low evens is going to be smaller than, you can't just end at the ones, goddamn. Because if you end at just the ones, then you're just looking at substrings where your starting and ending is like your odd count value. But your odd count value might not be minimizing, those substrings might not be minimizing the low evens. This could be like 1, 2, 2. So your low evens is like a substring between where your ones are. Huh. Okay. Oof. The acceptance rate has been slowly climbing as more people solve it, but not myself. Sometimes I wish they would just give me the topics. Should be a hint. But maybe that is a hint if it's just knowing what topics this is. I mean, ugh. Why do I always get stumped? Why do I always get stumped? Oh. Ah. Alright.